Super El Nino or Godzilla El Nino, nature's strongest driver, which was expected to weaken the monsoon of India. But what we are seeing today is almost 95% cloud cover in different regions of India. So is the Godzilla El Nino losing its power, or is there some other kind of battle going on in the atmosphere or sky above between the local weather conditions and the global weather condition? In this video, we will try to understand and decode in detail that why sometimes the local weather conditions are drastically different from the global atmospheric conditions or global oceanic condition. So first of all, to give a background of this particular topic, we are talking this or discussing this entire topic in the context of the Super El Nino that has developed this year. Super El Nino simply can be referred as such kind of weather system where extreme warming of the eastern Pacific Ocean is recorded, and generally such warming, unusual warming, is called as El Nino. When this warming is more than 1-2 degrees Celsius than average, then we can refer it as a Super El Nino. Super El Nino has strong impact on patterns of weather all across the world, including India. Generally, we see there is an inverse correlation between El Nino and the monsoon rainfall. Higher the stronger the El Nino impact, lesser is the expected monsoon rainfall over India, and this is expected to persist into early 2027 as well. Usually it weakens the Indian monsoon, as we have seen. So it is in this context we are being surprised because El Nino has developed, Super El Nino has developed, but also in India or over India we are seeing dense cloud cover. So before understanding all this situation, let us first understand how El Nino affect monsoon. Generally in the Pacific Ocean, and more specifically can say this is India, right? This is South Asia you have here, and here you have Australia, and this side you have South America. So generally what we observe is that the water near Australia is warm and water near East Pacific Ocean is relatively colder. When this condition prevail, basically monsoon is supported because warm air rises up here and then causes rainfall across Southeast Asia and India as such. Now, in the case of El Nino, warm waters that is near South Asia, or we can say Southeast Asia, Australia, it began to shift in the Eastern Pacific, and there is a kind of atmospheric circulation taking place in atmosphere called as Walker circulation. Whenever you have El Nino, Walker circulation becomes weaker. When Walker circulation becomes weaker, you have the dominance of dry air over India. Dry air means the moisture it would carry is very low because carries less moisture. It cannot condense. Cannot condense means no cloud formation, no rainfall. So cloud formation decreases, and it is obvious if cloud formation decreases, the seasonal rainfall that you experience in the southwest monsoon, that also would generally reduce as such. That's how El Nino generally is affecting monsoon. Now, before moving forward, I would want to bring your attention to the fact that Legacy IAS Academy, we're going to commence batches soon on 3rd of August, 7th of September, and 3rd of November. This is going to be the regular weekday batch. Weekend batches for the students who are preparing for examination along with the studies, full-time studies or job. They can also join our program, which will commence on 8th of August, 10th of October, and then 12th of December. Now, in this entire program, we focus on covering comprehensively all the papers of general studies from GS 1 to 4, and we know that just covering the topics in the class is not enough. Many times students require guidance so that they can stay right on track to clear the examination. So one-to-one mentorship, doubt solving sessions also provided here. Regular interactions with educators you will obviously have access to, and also to ensure that there is a good communication and interaction in the classroom itself, we focus on admitting maximum 40 students per batch as such. Now, apart from that, as UPSC requires an integrated preparation, daily mentions writing practice, and for evaluation, test series also we provide to the student as such. Apart from that, general studies, we know that is crucial in determining the whether you will be clearing examination or not. Apart from that, we know that the optional paper play a very important role. Many times it is referred as the rank deciding paper. So keeping that in mind, we are also going to commence optional classes from 17th of August in 4 most, we can say, preferable subjects in the UPSC, that is psychology, PSIR, anthropology, and sociology. If you want to know more detail about our course program's features, you can give a call to the number being displayed here. And also, you are welcome to download our Legacy IAS app, which will play an important role and a fruitful role in the UPSC journey. Now, coming back to the topic, why is India cloudy? Because we have seen that whenever you have El Nino, and this time specifically we have Super El Nino. So we should have experienced dry weather, low rainfall condition over India. So why is India cloudy? Why we have 95% of cloud cover? So it is because that super El Nino is one of the factors. Many other local and regional factors also influence the weather pattern, including monsoon. So scientists believe that multiple upper air cyclonic circulations have formed in the skies above India. That means cyclonic circulation means, suppose that this is the surface, and in the upper atmosphere you have low pressure. Because you have low pressure, that means you have less number of air molecule. So what we see is that from the surface, air start to rise up to fill this low pressure. Now when this air start to rise from the surface, they will also carry with themselves humidity, that is the amount of water vapor in the atmosphere. So all these water vapor are then placed in the upper part of atmosphere where they undergo cooling. Cooling results in condensation, and condensation then yields rainfall. Plus the condensation also is responsible for cloud formation. So that is one reason why strong convection, that means the upward vertical movement of air is being witnessed, resulting in the dense cloud cover. At the same time, in the Bay of Bengal, which is a very large source of moisture around India, a low pressure area has developed, which is further leading to the development of cloud cover. Monsoon trough is very important parameter or factor that influences the strength of rainfall, strength of the monsoon winds. So generally what happens, monsoon trough is a low pressure area that lies somewhere in the northern part of India. It keeps switching from north to south. That means in the southern part, it can reach as far as Indo-Gangetic plain, while in north, many times it goes and enter the Himalayan region. Whenever the monsoon trough is over the Indo-Gangetic plain, it basically acts as a suction and it pulls the moisture and the air from both Arabian Sea and Bay of Bengal. So you can imagine a large parcel of air from the Arabian Sea, Bay of Bengal enters and moves toward India. That's why the northern central part of India can see a dense cover of clouds as well as rainfall. So basically moisture is transported from both Arabian Sea side and the Bay of Bengal side. That's the reason why we are seeing a dense cloud cover over many regions of India, especially northern India. So monsoon trough and moisture transport, this is how we can understand. This is, as you can see, this is the location of the monsoon trough. This area, you can imagine that from here Ganga river is flowing through. This is your entire Gangetic plain extending from Uttar Pradesh to West Bengal. So it acts as a low pressure belt, and several weather systems also get linked together whenever this monsoon trough builds. So from Bay of Bengal, Arabian Sea, moisture is coming. So cloud will definitely develop, and also it will result in the heavy amount of rainfall as such. Now also other parameter or factor that influences the cloud formation and rainfall today is the cyclonic circulation. So we have development of a small scale low pressure system. Small scale, why? Because we are differentiating it from cyclone. In real cyclone, tropical cyclone, for example, when you see, you also have development of low pressure, but that develops over a large area, over 300 to 800 kilometers, sometimes extending up to 1000 kilometers and such. Compared to that, currently over India, we have a small scale, few hundred kilometers of the cyclonic circulation. Here, what is going on? So air converges on the surface. Air start to rush toward the surface, toward this low pressure area from all the side. And as it reaches the area where you have low pressure, where the heating is going on, air then is pushed in the upward direction, rising in the upward direction. And again, same thing is going on. As air rises, it transports the water vapor in the upper part of atmosphere, where the water vapor undergoes condensation due to cooling, resulting in cloud formation, and then that cloud can further produce localized rainfall. So apart from general circulation over India, many part of India, localized convection, localized rising and warming of air also is resulting in such kind of rainfall as such. So the El Nino, as we have discussed, is a kind of global atmospheric condition. So if the local conditions are favorable, they can temporarily overcome El Nino. So what we are trying to say is that El Nino or Super El Nino does not necessarily becomes weak today. It is simply being overcome by the local factors, and again after some time or long period of time, El Nino's effect can be seen over India. Then heat and western disturbances. We know that when you have less rainfall, and especially in the month of June, July, when the strong heating of the land surface takes place, intense heating creates again low pressure. As intense heating creates low pressure, the air rises up. So hot air basically is lighter. Hot air is having low density, so hot air rises. As hot air rises, what will happen? Low pressure would be created here, because atmospheric pressure is the force exerted by gases on the surface. If gases are moving away from the surface, you will have low pressure. Low pressure will attract the wind from the surrounding areas. So especially in the coastal part of India, the wind which is cooler over the sea, because temperature is less over the sea, the cooler wind start to rush toward this land, moves toward the land. And as cooler wind is coming from the oceanic areas, it is carrying lot of moisture. when this moisture reaches this region, it also start to rise up, and that's how you can have rainfall. Plus, in the northern part of India, in the states such as Jammu, Kashmir, Himachal Pradesh, Uttarakhand, Punjab and Haryana, you will see one other weather phenomena unfolding, and that is western disturbances. Western disturbances are basically the movement of wind and moisture carried by the subtropical westerly jet stream, and generally the origin point of this moisture can be considered as the Mediterranean Sea. So when these winds, the cold winds in the upper surface reaches the northern part of India, it collides with the moisture laden wind from the Bay of Bengal and some from Arabian Sea, and because of the interaction between the cool wind and the warm moist wind, you also see rapid condensation result in cloud formation that can also cause heavy rainfall as such. So western disturbances also scientists believe is one of the reason why effect of super El Nino has been kind of suppressed temporarily. The most important factor which can result into the weakening of the effect of El Nino over India or reduces the probability of drought over India is the Indian Ocean Dipole. Indian Ocean Dipole is nothing but it is a parameter that measures the temperature difference between the western and eastern Indian Ocean. Now imagine this is India and you draw a straight line through the middle of India, and this side you have Indian Ocean. So this part is what you can call as western Indian Ocean and this part is what you call as eastern Indian Ocean. When you measure the temperature difference between both of the ocean, that is what you call as Indian Ocean Dipole. Now, it has several phases. One is the positive phase. In positive phase, what we experience is that the temperature of Western Indian Ocean is higher, while temperature of Eastern Indian Ocean is lower. Whenever this situation exists or persists, moisture supply to the monsoon increases because more evaporation is going on in the Arabian Sea region, and the Arabian Sea branch contributes to higher rainfall over India. So, they bring more rainfall. That's why if the positive IOD develops at the time of El Nino, it can reduce the effect of El Nino. Now the question is that is it going on in the present situation? And no, the answer is no, because currently IOD seems to be in neutral phase. Now what is neutral phase? Neutral phase means the temperature of both western and eastern Indian Ocean are kind of similar. That's why you do not have any this negating effect on the super El Nino. No major support to monsoon is expected from the Indian Ocean Dipole, at least in this particular year. So that means this is not contributing to the heavier rainfall or dense cloud. Now also one thing we have to keep in mind is that when we talk about the global atmospheric circulation, we also look at the perspective of weather versus climate. Weather is something that we experience changing over a frequent period of time. It can be from hour to hour basis, it can be from day to day basis. Climate is something that we take as an average of the weather parameters such as temperature, humidity and pressure in a particular area for a long period of time, minimum 30 years or so. El Nino controls seasonal climate. On the other hand, local systems such as the strong convection, such as the western disturbances, such as the movement of the monsoon trough, they largely control the daily weather. That means both the climatic control can be acting over a long period of time and the weather control can be acting over a short period of time. Both act simultaneously. That's why you have daily changes in the rhythm of the weather, and this present development of dense cloud is an example of the same thing. The key takeaways from this entire discussion is that super El Nino still remains active. It has not weakened as expected. Regional systems are the responsible factors for the current rainfall. The examples we have discussed is in the form of the strong convection, the monsoon troughs location over the Indo-Gangetic plain, western disturbances carried by the upper atmospheric circulation referred as jet stream are responsible for the cloud cover. But one thing we can be sure about is that because El Nino still is active, super El Nino still is active, this cloud cover which you are witnessing is more of a temporary cloud cover. And when we talk about the deficiency of rainfall, we are talking about the deficiency of entire season that largely extends between June to September as such, because that is the advancing monsoon season. So when you look at the amount of rainfall India receives throughout this entire month, you will see that there is a kind of deficiency, there is a kind of shortage of the rainfall. That is because of El Nino factor. Within these 3-4 months, locally for certain weeks, certain days, you can have high rainfall, you can have dense cloud. That is because local weather system, regional weather systems are more active here. So seasonal rainfall deficit may continue and weather and climate would keep on operating differently. So this particular situation which we are seeing in India is not something extraordinary. It is simply a kind of convergence between the local weather conditions and the larger climatic conditions or the climatic factors. So possibility of super El Nino still is there. Deficiency we are expected to see in this particular year of monsoon. That's all for this particular video. I hope you got the idea behind the divergences in the local conditions and the global condition. Thank you very much.